Right then. Okay, so I think I'm approaching the end of fixing this, and what I've done is I've bought some of the opto-isolators that popped, the CQY80N from Farnell. Bloody good delivery by Farnell, by the way. Ordered it before 5 o'clock the day before, and it came the next day, which is pretty good going. So what I'm going to do is I'm going to take a look at this and the schematic, see what else could possibly have been taken out by that opto-isolator going dicky, and see if there's anything else that needs attention. I don't think it does, because even though the 1900 volt supply is dangerous, it can be shorted out very easily. All it is it's a Cockcroft-Walton voltage multiplier, or something similar to it, and the capacitance used to charge to build the voltage up aren't exactly massive, so I would expect that it's very easy to collapse the supply by simply putting on well, I wouldn't even say a very big load, you know, just enough, say like a leaky opto-isolator would be enough to collapse it. So I mean, I have worked on 1000 volt DC-DC converters before for photo multiplier, the tubes for detecting photons, and part of the criteria, because it was going to be in a released product, part of the criteria was that it should, the 1000 volt supply, when hooked up to a human analog circuit, and by analog I don't mean like analog electronics, I mean like a similar being sort of thing, that the supply should collapse, and I would expect the same sort of thing to happen in here. Anyway, sorry, I'm blabbering on. We'll have a look and see if anything else went bang. So if any of you's been following the stuff on the forum, you might notice that I put up a post saying that in the 203-7 manual there is a lot more to the testing and fault finding section than the 203-6 manual, and an interesting sentence in the 203-7 manual says, an absent trace in spite of correct plate voltages means a fault in the CRT circuit. The CRT circuit is this circuit. Now, I have found a fault in the CRT circuit, so it's that opto. And yeah, I did test the plates on the horizontal adjust and vertical adjust, and yeah, you can set them equipotential when measured between 0 volts and the either plate. So yeah, so we are in the ballpark, as it were. So what I'm going to do is I'm going to test all these components using continuity tester, resistance test, diode test. So I'll use the diode test for transistors and diodes. I know it's not you're not really supposed to test transistors like diodes, but you know, essentially the model, it can be based on 2 diodes, so you'd expect an equal voltage drop, CB and CE. Checking capacitors for leakiness, so you know, if you stick a voltmeter across it, an ohm meter, resistance meter across it, you'd expect the resistance to start rising unless there's something else in circuit. And diodes, obviously, they should have a typical forward voltage, 0.6 to 0.7 to 0.8 volts. Except for that Zener. There's a Zener on there, Z22. So I'm just going to check that and see if it's not leaky. I don't think it will be, because if it was, then the potential difference between there and there wouldn't exist. It'd just collapse. It'd just go straight through this diode and then straight through the center. So yeah, check all them and see what we find. Right, so I've checked all of them. They look fine. I can't find C512 for some strange reason. Never mind. Everything else looks fine, you know. Everything else is good forward voltage on the diodes. Used a diode check on all the transistors, and they showed the proper forward voltage and no leaks the other way. Good thing is that the manual does actually give you a pinout of all the transistors that are used. You know, all the different transistors they use, and a top view and a bottom view. So yeah, that's really useful, and that's something that people starting out doing this should pay attention to, and read the manual. You'll find lots of pearls of wisdom in there. So anyway, everything's looking alright, so I'm just going to go ahead, pop in that opto, see what happens. Okay, here we go. Moment of truth. Opto's in. He goes. Yes! Success! Woo! There we go. Turn the intensity down. I set all the X position, Y position levels, and as per the startup routine that's outlined in the manual. So everything's down. You probably saw me do it in the first video. All the push buttons are out, but yeah, woohoo! Yeah, nice one. Yeah, and you get movement side to side, movement up and down. Right, let's get a test probe on there and see what we can get. There we go, channel 1 with a test probe on. Beautiful. Beautiful, beautiful, beautiful. All nice and triggered. So yeah, AC triggering. There we go. TVH. Yeah. Well, yeah. Look at that. Okay, let's try the other channel. See if we get anything on that. Yeah, look at that. Both channels working. I've got it on dual mode. That is really nice. Cool. Right. Job done. Lid back on. Back on the bench. Sorry, Kikisui, you're going back home. Right, well, that's that then. It's fixed. Groovy. So, I suppose I should say thank you to some people. Thank you to Old Way and Tortec. Cheers, guys. Thanks for putting up with me. You can have a look at all the videos on my blog. I'll be putting this back up on the shelf and using it in anger. Hopefully, and I don't know, but hopefully I want to look at the component tester on this, because you can there's a lot of stuff in the user manual about this component tester, so I want to see exactly what it does. You know, because it looks like you can characterize things on it, but it looks like it's a special, like, stereo jack plug. I'm not quite sure. Anyway, good to have a good piece of kit. Now all I'll need to do is find a decent power supply. I have actually found one, and if you have a look on Tortec's website, he's actually got a picture on it. Switch mode, variable, 0 to 30 volt, 5 amp power supply, and it's in. And it being switch mode, it's quite compact, so it's about the size of that, if not smaller. So something you can just squeeze between, you know, stuff on your shelf. That wraps this up. So until something else gets broken, I'll be making some more of these videos. Oh, something else I'll be putting up on my blog in a bit is I managed to hack this Makita flashlight torch. Sorry, I am British after all. This Makita torch from horrible Stone Age filament bulbs, which are about 0.7 amp on a 1.5 a 1.3 amp hour battery. You know, it doesn't last very long, so I updated it and brought it into 21st century and gave it an LED. So yeah, I'll be outlining how I modified this. Anyone else with a busted old Makita is welcome to follow it. But yeah, it's so yeah, thanks for watching. Keep your eyes glued to my blog if you're interested. Next time something gets broken, I will be posting up some more findings.